Hello and welcome. So this is going to be a quick video, just finishing up on the topics from the previous one, where we're getting into packet capture and packet tracer, and kind of where I left off is as part of the one of the last examples that I was setting up for this lab is I wanted to have an access list that would block traffic specifically for this Ubuntu host on the far left. It's IP 10.50.3.2. And so as you can see on the screen here, it's the context here is the inside interface, and in the input direction or in the ingress for that interface. So anything that the Ubuntu would send to its default gateway hitting that inside interface, whether it initiates traffic or if it's a reply. And so basically it's saying deny this source IP to any destination, and then permit any other traffic, any source, any destination. So basically just blocking anything from this host to go off of its subnet. And so basically the problem with this example and the way that I was thinking about it is I was not taking into consideration the concept of stateful inspection. And so I think for most people that get introduced to firewalls, the concept of stateful inspection, like for the internet facing port, like outside interface, and the fact that if traffic is sourced from inside of the ASA and is forwarded out the outside interface, like for your normal internet access, then those concepts of stateful inspection, where since that's being actively tracked as a connection, then the return on that will be allowed through the outside interface, which normally has an implicit drop all traffic implicitly on that outside interface, except for the cases where there's already established connections that were sourced from the inside of the ASA going outbound on that outside interface. So that all makes sense, but what I wasn't putting two and two together on is the exact same thing can apply to the other interfaces and other scenarios on the ASA, just not just the outside and not just the internet facing kind of example that most people are familiar with. So basically, yeah, just to recap, we have this as part of this example. There's an access list that's meant to block any traffic from the Ubuntu host on the left. And then let's look at two examples from Packet Tracer. This first example from Packet Tracer is going to be where a scenario where the Ubuntu on the far right is wanting to establish SSH connection with Ubuntu on far left. And when it creates the packet for that, the destination IP or the destination port is going to be 22. And then the return to that, the SYNAC for the TCP handshake, is going to be source port of 22 and then some random TCP high port like 1024 or above. So this packet tracer setup here is meant to simulate the response from the Ubuntu on the far right initiating SSH traffic. Now, what we see here in phase two is it's saying that it's going to drop that traffic based on the access list that we just went over. But in fact, that's actually not true in practice, because if I want to SSH to it, then I can. And the reason for that is because of stateful inspection. So as we can see here, I'm able to go from the Ubuntu on the far right and SSH into the Ubuntu on the far left. And but packet tracer is saying that is basically saying no, that actually would be dropped. And so the point here is that packet tracer is an awesome tool, but there's no way for it to at least in this example to take into account the stateful connection that this would be a reply to. So basically, when that initial SSH connection is being established, that's being tracked for stateful inspection on the ASA, on that inside interface, which it was forwarded out. When the response from the Ubuntu on the left comes back, that's as ingress traffic on inside interface, that's being seen as a valid connection that's being managed by stateful inspection. And so the access list on the inside interface that's meant to deny anything from the Ubuntu on the left is not taken into account. It's not evaluated because it's allowed statefully. Now, another packet tracer example that most certainly will be correct is, for ping traffic as an example. And the difference here is, there's no concept of a stateful connection here. This is just the Ubuntu. It doesn't have to be ping. It's like any traffic that the Ubuntu is the source of and shows up as ingress traffic on the inside interface where there is no existing stateful connection, then yes, absolutely, the results in packet tracer here are going to be correct. So again, phase two, it's hitting the access list and it's being dropped. And if we go to try to ping this Ubuntu on the far right, it doesn't ping because of that access list. And just to kind of demonstrate that, so if we get rid of the access group, so we do show run access group, and then we do a no to that, to take that out, then we should be able to ping, because now we've dropped the access list. And then sure enough, it goes through. And then if we were to run packet tracer again, then we can see this starts to be allowed, which makes sense. So yeah, basically just wanted to make another video to kind of wrap up this initial look at packet tracer, packet capture, and then the whole part that I was missing, which I'm glad that came up and I had to think through it, is, when you have access lists on the ASA, don't treat it like a router access list. You have to consider stateful inspection, and there's going to be cases where when that's happening, the access list is not going to be evaluated. And so definitely a good thing to test out in the lab and get a better understanding of, and so on and so forth. So yeah, appreciate taking the time to watch, and we'll catch you next time.